Hello guys, welcome back to Maths on African Motives. Still working on our mathematics and five. In this platform, we shall actually be focusing on our integration. We remember we had our basics of our integration and some of the questions basically on the integration on its own. So we shall be focusing on the applications of that integration that we have been referring in our previous classes, but now working on the area. And also on this area, it's not just area, but it must be the area bounded by a curve and a reference axis, because we shall have another part where we shall be focusing with the given two functions or two curves or two graphs. But in this case, we are just focusing with a single curve being bound, the area being bounded or being covered by that curve with a certain reference axis, which can be the x-axis or it can be the y-axis in this case. All right, so we've got two axes that we have. So we're just going to have a sketch of what is it that we are actually referring to. Let us say we've got the area that, remember you're talking about the area in this case. So we want to see how integration is going to affect this area. All right, so let us start by the area in the x-axis, all right, in the x-axis in this case. So given a curve, in this case, let's say we've got a function that we have of f of x that we are given. In this case, just gonna have a sketch of this nature. All right, this is our function f of x. It can actually be something of this nature. I hope you understand what I'm trying to say. So this is y is equal to f of x. For an example, we are given y is equal to 2x squared plus 3x plus whatever that you are given as a quadratic graph in this case, or as a quadratic function, or it can be a linear function, y is equal to 2x plus 3, as long as y is equal to x. It can be any sort of a function. So it can be given even as a linear function like this. It can be any function. It can be a logarithmic function. It can be an exponential function, whatever type of a function that you're given. So considering to say that we have got this function of y, which is equal to f of x, and we want to calculate the area that is bounded by a certain section. To be bounded, we are saying the area covered by this curve. Let's say it is covered between the points. We are given the values of x across this point at A, and the other value of x across this point maybe at B, like this. We are talking about the area being covered, bounded. To be bounded is to be covered like this whole section of this area that we have here. So let's say this is the area that we want to calculate or that we want to determine, which is in the x-axis. So in the x-axis, it means that we are going to have the representative strip in the x-axis in this case. So I'm just going to indicate our representative strip in this case like this, which is in the x-axis. So meaning to say we shall have this with respect to x. All right, the area that we are talking about, whether it's with respect to x or with respect to y, what is this area? Okay, because here we are talking about x, focusing on x. It can be on y, we shall talk about that. But the area that we are simply talking about, it's simply the integral of the function of x that you are given with respect to x. If you can integrate for a certain function that you're given the limits, maybe from A to B, that is the indication of the area. So it can change depending with, is it with respect to x or with respect to y. So the area is a direct application of an integration. When you talk about the gradient, we talk about the derivatives. But for integration, the application that we talk about is on area. Also, we shall see the other application on volume. All right, so let us have this. So like I was saying, this is just with respect to x. That means, remember, on your integral, there is the change of x or the change with respect to y, depending with what you're given. That is what you have as our representative strip. So our area is going to be calculated from A to B, from A to B, bounded between this graph. So that is the area that we're going to have with respect to x. So our area is going to be given, the area with respect to x is going to be the integral of f of x, which is the function that we have with respect to x, in this case, taken from the lower limit a to the upper limit, which is b. So this whole f of x is the one that you're saying y is equal to f of x. So meaning to say we can just write in simpler term as the integral of y with respect to x, all right, given the limits a and b. So that's y representing a function of x. Y in this case is a function of x. That is why we are supposed to integrate here with respect to x. So the limits are a being the lower limit as we have from this part, and b being our upper limit. Remember, we talked about this on the issue of limits when we use our limits. So I think we have that idea where we said we are going to use the upper limit minus the lower limit to find the value. And also when the limits are included, there is no need for us to even to include the plus constant of integration when you are integrating, because you've got the limits there, the c and the c will cancel. So those are some of the things that you can also put in mind, because we talked about that as a separate part. So that's how you calculate your area. So it's simply an integral. So area, guys, is just the integral. You just have to consider your function to know your function back to the sketching of the function. Is it a quadratic? Is it a linear function, which is a straight line, an exponential, a logarithmic, whatever type of graph that you're given, you are supposed to know it so that you can know the sketch of that graph, present the graph and the points that you're given. Then you integrate, substitute your limits. That's it. All right, so we are going to have the same scenario in this case of this area, but it will be in the y-axis. So let us just say for the first part here, in the x-axis, then we're gonna have another part of the area, but in the y-axis. So we're gonna have our area in the y-axis in this case. So the area in the y-axis, from the same concept that we are having there, we're gonna have our sketch. Let's say we've got x and y in this case, and we've got a function presented in this manner. Let us just say we've got something of this nature. All right, taken at certain point. In this case, we used a and b as our limits. So for the y-axis, we can just use c and what? C and d. So you can just say this is our c, this is our d. So let's say we are to calculate the area that is bounded between this whole section that is covered by this graph that we have. It means we shall have the representative strip in the y-axis, because we're saying with respect to the y-axis. So this is going to be our representative strip in this case with respect to the y-axis. And this is the function that we're talking about. But this time, if we are to have our integral, because it must be with respect to y, so meaning to say whatever that you must integrate must carry y. So it must be a function of y in this case, so that we'll be able to integrate this with respect to y, just like what we had in this case. We've got a function of x, so that we can integrate this with respect to x. So meaning to say, in order for you to have a function of y, we are going to write this as x is equal to f of y. Just like you've got, okay, let me just represent maybe just a smaller part. Y is equal to 3x plus 1. This one is we've got a function of x, y is equal to f of x. So this is y is equal to f of x. This function here is written in terms of x. But if we are to write x as a function of y, it means we must have x as the subject in this case. So given y is equal to 3x plus 1 like this, you can simply transpose y minus 1 is equal to 3x divide by 3 each and every term, or just write it like this. So 3 is equal to y minus 1 over x is equal to y minus 1 over 3. So this now is a function of y that we have. So you can relate x to y. So that means x is equal to f of y. That is what we can have in order for us to have this in terms of y this side, so that we'll be able to integrate it with respect to y. So if we've got y here, therefore write your function in terms of y. If you've got with respect to x, write your function in terms of x, which is f of x, all right? So we saw that x will be equal to f of y in this case. So that means our integral, just like the previous part, we're going to have this integral as, all right? So you're just going to have our integral of the area. with respect to y in this case, which is going to be the integral of, given our limits, we say this time we're going to have c and d. So these are the limits that you're going to have, c and d. Then f of y in this case, which is the function of y with respect to y. But this function of y here is better presented as x is equal to. So you're going to write it as x there, just like the previous part. So that means the area with respect to y is going to be the integral of x with respect to y with our limits c to d, whereby x is a function of y. This x here represents a function of y. And this y here represents what? F of x, just like the previous part. All right, so that is what you're going to need on the calculation of your area. If we are not presenting a condition of area between two curves, that one we shall have it as a second class after this. But here I just want us to focus on this and also understand in the sketching of our graphs and how are you going to present the bounded area depending with the information that you be given. So it's going to depend with the information that you be given in that case. All right, so let us check some of the examples that we might be given. In this case, we've got questions that is to calculate, we asked it to calculate the area bounded by, calculate the area bounded by. All right, so we've got different curves that you're going to focus with, or different graphs that you're going to focus with. All right, so the first one is the graph of y is equal to 2x plus 1. All right, following that, it is covered between the x-axis. All right, the y-axis, we also have the y-axis there, and the line x is equal to 3. All right, so you'll be given a certain information like that so that you'll be able to know exactly the area to use, because it's bounded. Take note, this area is bounded. It's the area that is being covered between a certain region. It must be taken between some certain point that is to be covered between the graph that you're given, the x-axis, and the lines that you'll be given depending with the information that you have. So in this case, if you have to check here, we are given a straight line, y is equal to 2x plus 1. This is a straight line that we have. So all you need is to have our sketch. Then we present our information properly. So that's for a straight line. You can even maybe have your table values. If you understand from that concept, you've got x values and the y values in this case. All right, let us just say maybe 3 points will be enough. So if we have got a sketch that is being taken, let's say we have got the values of x and the values of y in this case. I'm just going to have it as a sketch. So it depends, maybe we're going to need negative values, positive values. It's up to you in your simplification. So you can just maybe pick 1 or 2 values of x that you can use. Maybe you can pick your x being -2, your x being a 0, your x being a +2. So these are the values that you are picking from the x values. Maybe we've got a -2 here, we've got a +2 there. All right, so you're going to take the values of x according to what you are given, in this case, on your Cartesian plan. Just any values of a choice, you can pick -3, -1, and whatever that you want. Then you substitute into your equation to find the corresponding values that will be of your values that you have picked here. So for -2, we are going to have a -3 in this case. All right, we can just have our calculator so that we do not waste much of the time here. So let me just show the part of the calculator so that we can work from it here. So this is 2 into, if we are to simplify, that's 2 into -2. That's into -2 like this, plus 1. All right, so that's it. We are going to obtain -3. So this will be a -3. When x is equal to 0, you do the same thing. Where there is x here, we're just going to put a 0 there. That will be +1. When x is a 2, just going to have the same thing. Where there was x here in the side bracket, that will be a 2, which is 5. So we are going to have our x being a 5. So these are the points that you are going to mark on your graph in this case. Like here, I'm just having a sketch. So I've got -2 versus -3, maybe somewhere I've got -1, -2, -3, -4, I've got 1, 2, 3, 4, 5, and so on. These will be the points that you're going to have, and you mark accordingly. Now, -2 and -3 may be somewhere here, X and Y value where they intersect, you mark that. 0 and 1 may be somewhere here. 2 and 5 maybe somewhere here. So this is just a sketch to show the information that you're given in this case. All right, so this will be our graph as it's going to be continuous and so on and so on. All right, so that is the graph of y is equal to 2x plus 1. So with the information that we are given here, we are told that the area is supposed to be bounded by this graph, the x-axis. So we are now left with the space between, this is our graph here, the line, the x-axis, meaning to say we are talking about this region that is to be found here. All right, and also at the same time, the y-axis is supposed to be included. This is our y-axis, and the y-axis represents x equal to 0. Along the y-axis, the x values will be equal to 0. In the x-axis, y will be equal to 0. So when bounded by the x-axis, it's bounded by the line y is equal to 0. And also you've got the line x is equal to 3. All right, having the line x is equal to 3, maybe somewhere here at the point 3 in this case. It means the region that is going to be left bounded, because we have got the y-axis involved. The region that is going to be left is this part here from 0 to 3, this part between the line, the x-axis, the y-axis, the line axis, x is equal to 3. This is the region that will be left bounded. We can't be referring to this. It's out of the graph. It's not covered. It's not bounded. To be bounded is to be covered by all the lines that we see. X-axis is there. X is equal to 3 is there. X is equal to 0, which is the y-axis, and the line that we are given. So this is the region that is going to be left in between like this to be calculated its area. So we are going to apply now to say this one, the best representative strip is going to be in the x-axis. So we're going to have our area like this, the representative strip here in the x-axis. So we're just going to write with respect to x. So we're talking about the area being taken, or the area being covered from 0 to 3, that is in within like this part. All right, so this is the whole part of the area that you're going to be talking about, or that you're going to be representing from 0 up to 3. So from 0 up to 3, that's it. So having our representative strip with respect to x, it means our function must be written in terms of x. So that's, we can calculate our area. Remember, area is simply the integral with respect to what you're given. So the area with respect to x is going to be the integral of the function, which is y, with respect to x, with the limits a to b. So that's it. Our area is going to be the integral of y in this case, which is the function that we have with respect to x. So that is going to be 2x plus 1. With the limits, the lower limit, as you can see from the region that we are taken from 0 to 3, the lower value is at 0. Then the upper value is at 3. So it's going to be 0, 3 in this case. All right, so this is it with respect to x. So once we integrate this, we substitute our values, we have the area. That's how you calculate your area. Simply, we have to apply our integration. So we are back to the integration. Remember, from this part, we are going to add 2x to the exponent of 1, that is 2x. So we have to add 1 to the exponent, and we divide by the new exponent of 1 plus 1. So if we add this, will be 2. 2x to the exponent of 2 over 2, that will be x squared in this case. All right, so that is area with respect to x is going to be x squared. The integral of a constant with respect to x, that will be x. So it's going to be plus x in this case. So this part, if you do not understand the part of integrating, you have to check back to the introduction, that part of integration, so that you know what exactly is happening. But as you can see, this one, I think it's clear now. So you just have to substitute our values. The upper limit is 3, the lower limit is 0. So it's going to be upper limit minus the lower. So it's upper minus lower in this case. All right, so you substitute what is in the upper limit as 3 wherever there is x. So that will be 3 to the exponent of 2 plus x, which is 3, minus the lower limit where x is a 0 in this case. So in place of x, we're going to have 0 in this case, of which 0 squared is just a 0. So that will be a 0 in this case. So this is our area with respect to x. So if they simplify this part, 3 squared plus 3 is going to be 12. So that will be 12 minus 0, which is 12 square units. All right, so that is our area with respect to x, which is 12 square units like this, or you can just write as 12 square units like this, all right, which is unit squared. So the units of area is to the square of that unit if it is centimeters, square centers, but here we do not have centimeters or meters. We are just using it as a unit. All right, so that is how these questions will be given on your calculation of the area bounded by a certain graph or a certain function that you'll be given. All right, so you just want to check another part of a question in this case about this area, in this case, bounded by a certain graph, and how are you going to calculate your area in this case. All right, so let's say it is bounded between the graph of y is equal to e to the exponent of 2x in this case. We put e to the exponent of 2x between the x-axis, the line, it also between the y-axis. All right, that's also between the y-axis and the line x is equal to 3, and the line x is equal to 3. All right, so this whole part here is the one that is referring to the bounding part in this and that. But what we are focusing on is the function that we are given, y is equal to e to the exponent of 2x. We are supposed to have a sketch of this function, then we can tell the area that is bounded between that part that you be given. All right, so remember for the exponential function, we also talked about this from our sketching of the graphs, that an exponential function is the one that we're going to find in this manner. Even if you are to check on your calculator, you can just even try your values, like let's say we've got 0 in this case, -1, -2, 1. So we just use values so that we can see how the function is corresponding, or how this function is actually relating as the values of x are changing from one point to another. All right, so let us see from our calculator, but you are supposed to know your graph. Yes, to check in exam condition is actually fine. So this is 2x, we can just try -2. If x is -2 like this, you're going to have 0.0. This is very, very small. That's a very small value. All right, we move on to -1. Let us check again. Again, this value is very small, but it's getting up, all right? Then if we move on at 0, it's going to be at 1. So at 0 here, it's going to be at 1. So meaning to say we're going to have 1. So the graph is actually going up, as you can see. If you check again, let's say you move on to 1, you're going to see that your graph is now going up. All right. So as you can see now, 7, the graph is going up now. All right. If we move at 3, we're going to see 400 and something. So the graph is now continuously going up. So that means you have to know your exponential function, right? So as you can see, the exponential function, these values, they'll be very low to the negative. As our values are increasing, the values of y, they'll be increasing sharply, going up. That's the value of y. They'll be increasing sharply in this case, all right? So that is the sketch of our graph, where at 0 here, the value of y is at 1. So that is the function of y is equal to e to the exponent of 2x. So with the information that we have here, let us relate. We are saying it must be bounded, covered by this graph. The x-axis, which is the line of y, is equal to 0. The y-axis, which is the line of x, is equal to 0 in this case. We need to say the line is considered, which is our x-axis. The y-axis is considered. So the region that is bounded is either we are left with this side or we are left with this side. So that is where now we are given this line, and x is equal to 3. So the moment we put the line of x is equal to 3, it means we are no longer limited, because here there's no limit here. This is an open space, so you can't use that side. We are just left with this side from 0, because we are considering the y-axis at x is equal to 0. So you're going to start from 0 to 3 in this case. So this is the region that actually you're supposed to find the area bounded, the area covered on this part here. So this part the representative strip that will be best is to be on the x-axis, since our limits are on the x-axis 0 and 3. Here we do not have the value that corresponds there. So it's going to be a lot of things to consider there. So that is the best part, to have our representative strip in the x-axis. So that's what you're going to have, which is with respect to x. So you're going to calculate the area. So as we can see, our representative strip is with respect to x and our function is with respect to x. So we can calculate our area, since our area is going to be the integral of y with respect to x, taking our limits from a to b. That is the area with respect to x. So the area with respect to x is going to be the integral of y, which is a function of x. Y is the function of x. That is e to the exponent of 2x with respect to x, with our limits now taken from where? From 0 up to 3, the one that we are given at the end. So that's 0 to 3, the lower limit and the upper limit. So all you're going to do is to integrate e to the exponent of 2x in this case. Remember, we have this from our integrals, from our formula sheet and so forth, but the e, it is the integral of e to the exponent of f of x with respect to x like this, we're gonna have e to the exponent of f of x, which is multiplied by 1 over the first derivative of f of x. So it's 1 over f of x times this plus c. So it's simply e to the exponent of f of x over its derivative. That's what we are simply having. The e to the exponent of f of x over its derivative. That's the integral of e to the exponent of any function. So meaning to say, if I'm given e to the exponent of 2x, it's going to be the e as it is e to the exponent of 2x over the derivative of f of x, which is 2x. So the derivative of 2x is going to be 2. So that's, I have integrated this part, okay? So that means the area with respect to x is going to be e to the exponent of 2x over 2, with our limits in this case 3 and 0. So that's how we can play around with the integrals. So at this stage, it's now upper limit minus the lower limit. In this case, just going to have to substitute, just like the previous part that we had. If we had to substitute the area with respect to x, it's going to be upper limit minus the lower limit. In place of x, we are going to substitute 3. So that's e to the exponent of 2 times 3, everything over 2, minus the lower limit, which is e to the exponent of 2 times 0, in this case, over 2. So that's it. We can have the value of our area if we substitute properly. That's 2 times 3 is 6. So meaning to say, this will be our area with respect to x is going to be e to the exponent of 6 over 2 minus 2 times 0, that's 0, and e to the exponent of 0, it's 1 over 2. Remember that any number to the exponent of 0, it's a 1. So that means we can be able to simplify this on our calculator. So if we are to have this, we can obtain, let us just see what we're going to have from this part. That's e to the exponent. So we're going to need a fraction, and we've got e to the exponent of 6 over 2 in this case, okay? Then minus 1 here over 2. That's 1 over 2 like this, which is going to be 201, comma this. So you can change this to 3 decimal place, which is shift setup. Gonna fix this to right to 3 decimal place. Gonna press 3 there. So it will be 201, 214. So that's our area. With respect to x is going to be 201, 214 square units. So like I said, you can write square units, or you can just write u to the exponent of 2 like that. It means square units in this case. All right, so that's it. That's how we can simply obtain or determine the area. So this can be an extended part. It's not like you're just going to be given simple curves like this, or simple graphs like what we see here. There's a condition like this type of a question that I want us to see, that the area also can be affected with the region where it is calculated. The area can be affected with the region where it is calculated. What am I trying to say? Let's say we are given a condition of a trig graph. It can happen for a trig graph. Let's say I've got the graph of cos of sine of x. Then I'm just going to have another example like this. when you are given a function of this, the area that you calculate above the x-axis, this one, is going to be a positive area. The area that you calculate below is going to be a negative area. That's how you are going to have your areas at the end. So whenever you're given a trig function, you're supposed to be very careful about which region are you going to have your area. Like for this one, we are given the graph of y is equal to the cosine of 3x with the limits y is equal to 0, that is the boundaries x is equal to 0 and x is equal to pi over 3. All right, so if we are given this x, remember y is equal to 0. When y is equal to 0, we are talking about what? We are talking about the x-axis. X is equal to 0, where in the y-axis, we are given the boundaries of the x-axis, y-axis, and the line of x is equal to pi over 3. So that means we are referring to our angles being in radians in this case. All right, remember the graph of cos of x. Yes, if you know the sketch is fine, but you can even use your calculator because this is, a table of values so that you can have a sketch. Let's say I've got the x values and the y values. So if you have to check pi over 3, remember pi is same as 180 degrees. So it's simply, you've got 180 divided by 3, which is something like 60 degrees. So it simply means we've got an angle of 60 degrees there. All right, let us just see from this part what I'm trying to say. All right, just gonna go back to the normal setting. That's 8, 2, like that. All right, so I'm saying pi, it's 180 degrees. So 180 degrees divided by 3 like this, it means we've got 60 degrees. So if we are saying this pi over 3, it's 60 degrees. So they are saying we are supposed to be limited to 60 degrees in this case, which is pi over 3. But as we know that these angles can be converted to radians, can be converted to degrees. So as we are used to the degrees, but we're given in terms of radians. So we're just going to use the degrees so that we properly see how our angles are going to be separated. But as you write your angles, you just write them in what? In radians as you are given. So the degrees part is just going to help us just to properly see how are we going to locate our angles in this case. All right, so like I said, we've got the x values and the y values. And as we are limited here, we are limited to x being equal to 60 degrees, which is pi over 3. And we can see that this is the graph of cos 3x, which affects even the whole interval of our graph is going to be affected in this case. So if we are given the graph of cos 3x, if it is cos x, it is going to be taken from 0 to 360 degrees. It completes its revolution, its complete cycle at 360 degrees. But if it is 3x, it affects even the interval, even the ending part, it is going to be affected. So if on our normal table, we used to use a separation of 0 degrees, 90 degrees, and so on, it is going to be affected also by this 3x because we are no longer ending at 360 for us to have a complete cycle. So it affects even our separating angle, this 3x. So if it is 90 degrees, we divide it by 3, that will be 30 degrees in this case. So meaning to say we can separate our angles as 0, 30 degrees, 60 degrees, up to 60 degrees. Yes, we can just maybe add another angle, 60 plus 30, that will be 90 degrees in this case. So meaning to say these are the angles that we are supposed to have, but we are supposed to have these angles now in radians since we are given this in radians. So you can just convert, remember, we indicated that pi is equal to 180 degrees. So if I want to convert 30 degrees to radians, I simply divide 30 over 180 degrees times pi in this case. So it's the angle that I'm having in degrees over 180 times pi. So that is the condition that you're going to have. So here, 0 is just going to remain like that. All right, 0 is not affected. So that we're going to just have it as we move on to the next one, which was supposed to be 30 degrees, but we write it in radians. So it's going to be 30 over 180 times what? 30 over 180 times pi. So you can just simplify from our calculator. That's 30 over 180 in this case times pi. So you're going to multiply this to pi. This is going to be 1 over 6 pi, which is same as pi over 6. All right, so this here is same as pi over 6. We move on to 60 degrees. 60 degrees is the one that we are already given as pi over 3. Remember, I talked about this. So that is our pi over 3. Then 90 degrees in this case is going to be 90 over 180. So that one is going to give us pi over 2 if we simplify properly in this case. So these are the same angles that we are simply talking about that we had before, the 0 degrees, the 30 degrees, the 60 degrees, the 90 degrees, but we're just writing these angles in radians. Then we simplify according to what we are given, that y is equal to the cos of 3x. So on our calculator, we're going to refer this as it is, that is y is equal to cos of 3x. And at that moment, our x is equal to 0. So you're going to have cos 3 times as 0 in this case. And this must be in radians, since these angles are in radians, pi over this. So we're going to have our calculator in radians. So that will be a 1 in this case. Okay, we move on to this part. If our x, which is pi over 6, so you're going to substitute in place of 0 here. Now we've got pi over 6. So that is pi over 6 like this, which is a 0 in this case. Then pi over 3, our x this time is pi over 3 like this, which is going to give us -1. Then pi over 2 for 90 degrees, you're going to have pi over 2 like this, which is going to give us a 0 like this. All right, so these are the values that will correspond to the x values that we are given here. So with these values that we have, what we can simply do is to have our sketch. Now we can have our sketch from 0 to 90 degrees. That is from 0 to pi over, actually supposed to take from 0 to pi over 3, but just extend so that you can properly see how your graph is supposed to be like. All right, so that is our x values here. We've got our y values from 0 to pi over 6. All right, so that's pi over 6. Then we move on to pi over 3. All right, we've got pi over 3, then we've got pi over 2 for 90 degrees. All right, so if we are to mark our points, we're going to see that the higher value or the maximum value that we have here is a +1, and here it's a -1. So you're going to have 0 versus first point, that's 0 versus 1 in this case. All right, so we've got 0 versus 1, we mark our point. Pi over 6 versus 0, we mark our point. Pi over 3 versus -1, pi over 3 versus -1, which is somewhere here. Then pi over 2 versus 0 like this. All right, so this is the graph of course. Remember, the graph of course is something of this nature. So as you are even sketching your function, you are also ought to know how the graph is supposed to be like on your sketch. So you know that the graph of course is supposed to be somewhere like that. Okay, something of that nature. So you can just indicate something of this. All right, so that is the graph of y is equal to the cosine of 3x. But now, because of the interval that you're going to consider, or where you are going to consider your area to be taken, there's a lot of things that you have to put also in mind here to say, I'm given my area is supposed to be bounded between this graph. Remember, it's supposed to be a bounded area between this graph, the x-axis, which is the y is equal to 0, which is the x-axis in this case. The y-axis, which is the line x is equal to 0. So meaning to say the area to be bounded is supposed to be between the graph, this one, the x-axis, all right? And we also have the y-axis there. So meaning to say this part is taken up to, and also x is equal to pi over 3, x is equal to pi over 3, which is this one. So you've got two regions, because this one is bounded, the y-axis is there, the curve is there, the x-axis is there. So meaning to say this region is not supposed to be omitted, this one. This region is supposed to be taken. So we're going to consider from 0 up to pi over 6. Then also because pi over 3 is there, this region we've got our curve is there, pi over 3 is there, the x-axis is there. So this region also can be taken. So meaning to say we are going to consider also this region here. So this is where we are going to have our area in this case taken from 0 to pi over 6, then from pi over 6 to pi over 3. So I'm going to consider these two sections separately, because this is an area on its own. And if you still remember what I said before, that the area that is above the x-axis is a positive. you are going to have a positive area. The area that is below the x-axis is going to be a negative in this case. But as we are supposed to obtain, let's say this is the first area and this is our second area. We are supposed to combine these two to give us a single area. That is from what you calculate from a to pi over 6, from pi over 6 to pi over 3. You are supposed to combine that. So meaning to say your total area is going to be the sum of area 1 plus area 2. But for area 2, because you know that it's below the x-axis, is going to be a negative. It means you are going to add the magnitude of the area. When I'm saying the magnitude, I'm saying the answer is going to be a negative, but you take your answer as a positive, that you take the positive value, that is the magnitude of area, the positive, not negative. Or you can simply write your formula as the area is equal to area 1 minus area 2. But when you use this, you are not going to consider the magnitude of area. You are going to take the area as it is. If you obtain a negative, you just write your negative 2 as it is. But for this one, if you put a plus like this, you're going to use the magnitude of the area that you are given, the magnitude of area. So this, we are going to consider the magnitude of area of the area in this case, the magnitude of the area, which is the positive value of the area. If your area is a negative, you take it as a positive. Area is positive. Don't consider to say it's negative. You put it as a positive. That's what I'm trying to say. All right, so that's it, guys. As we can see, the area, as we are talking about the representative strip that is going to be best to use is with respect to x in this case. So we are going to have our representative strip with respect to x. And with this representative strip, we can combine these areas from 0 to pi over 6, from pi over 6 to pi over 3. So like I said, you can use area 1 plus area 2 as long you are working with the magnitude, or you can use area 1 minus area 2. It's one and the same thing. All right, so that means our area is going to be remember the area is the integral of y with respect to x. So y in this case is cos 3x. It's going to be the integral of cos 3x with respect to x, taken from 0 to pi over 6. All right, so our lower limit is 0, upper limit is pi over 6. All right, so if I add, it means I'm going to take the magnitude. The answer will be a negative, but I take the positive value. If I subtract, therefore, I just use as it is, all right? So I'm just going to, but I wrote here magnitude of area, all right? So it's gonna be from the area 2, it's from pi over 6 to pi over 3. Those are the limits. So it's gonna be lower limit will be pi over 6, and the upper limit is going to be pi over 3, all right? So that will be the cosine of 3x with respect to x. What just changed here are the limits. This part above the x-axis is taken from 0 to pi over 6. This one below, because they are different in their cross-section. So we're going to say we're supposed to separate them. But any area below the x-axis is a negative. Any area above the x-axis is what? It's a positive. So that's what you're gonna have. So here you can simply find your area by integrating. Remember the integral, of course, is going to be sine over, you divide by this number 3. So it's gonna be the sine of 3x over 3 in this case. All right, so you're gonna have our limits from pi over 6 to 0 minus, sorry, that's a plus here. We integrated this, but it's the same as this one. The integral, of course, again, is the same. So it's going to be the sine of 3x over 3 in this case, taken from upper limit, that's pi over 3, the lower limit, it's pi over 6. All right, so we have integrated the cos, so you're going to substitute. So this is the first area, so do not combine this, because remember, we are supposed to take the magnitude. So you're supposed to find this answer in its simplest form first before you just combine everything. If you combine everything, you're going to obtain wrong values there. So the area, you're going to substitute for the first one. Our area 1 is going to be upper limit minus lower limit. In place of x, you're going to substitute pi over 6. All right, so that's a lot, but let us just write sine 3 times pi over 6 like this over 3 minus the lower limit that says 0. So it's going to be sine 3 times 0 like this over 3. All right, so this is the first area plus the magnitude of the first area, the second area, which is upper limit minus lower limit, which is sine 3 times pi over 3. So I explained in another way, or in another video where I used minus. So this one, I want you to know also this one. All right, minus the lower limit, which is the sine of 3 times pi over 6, everything over 3. The moment we use these values in pi, there is no degrees there. These values are in radians. So meaning to say your calculator must be in radians in your simplification. So this is what I'm trying to say. Yes, you can simplify this whole area, get a single answer there, but do not combine to the other one, because there we need the magnitude there. So you're going to have it this way. Let us just save our calculator, like I said, in radians. So we're going to just save our fraction, which is sine 3 times pi over 6. So that's pi over 6 like this over 3. All right, then we're going to subtract sine. That's 3 times 0, which is 0 there. Sine 3 times 0 is simply 0. If you can just even multiply if you want, but that's a 0 there over 3 in this case. Okay, so that's it. Close this bracket. We are going to obtain, there is something that we missed, which is this, which part there. All right, let me just check. I suppose we have negative fraction like this. We've got the sine of 0 like this over 3. All right, why are we saying it's a math error there? All right, so I just think maybe there's a bracket that I skipped, or a bracket that I closed that I'm not supposed to close. Maybe it's this last bracket here, because I do not remember opening. Yeah, that's 1 over 3 there. All right, so this is going to be a 1 over 3 if you simplify. So this is what we are having from the first area, which is our area 1 in this case, okay? Plus, you are going to see that if you simplify this area to this one, it is going to be a negative. So this is what I was saying, that do not combine the simplify each separately. All right, so if we simplify for the area 2, we are given the sine. So I'm just gonna have fraction. That's the sine of 3 times pi over 3. So that's pi over 3 like this. All right. Everything over 3 minus the sine. So you're gonna have the sine. All right, let's just do we have a negative? Okay, we do not have a negative there. You're gonna have a minus there. All right, then a fraction. We have got the sine of 3 times pi over 6. That is pi over 6 like this. All right, then we're gonna have everything over 3. So that's it. We are going to obtain negative 1 over 3. If you were to combine, you see that this will be 1 over 3 plus minus 1 over 3, which is a 0. You'll be wondering what exactly is happening. No, it's because this part is in the negative region, so it gives us a negative area. So, but as we need the magnitude of area, so if the negative is the region, to say it's down, it's below the x-axis, but what is the magnitude of area? The magnitude of area there is 1 over 3. So our area is going to be 1 over 3 plus 1 over 3, which is going to be 2 over 3. That's something like 0.666 and so on, 0.667 square units. So we need the magnitude of area. If we are saying the area is -2, it's just because it was found down. But the area here, it's 2 square units. This is the area that you'll be given. If it is 3, it's 3 square units. But because of the region where you are presenting your answer, that's where you can have the negative on your calculation. But the area, we want the magnitude value. All right, so that's how you can have this. Remember, I explained this same calculation with the formula for area using area 1 minus area 2. Yes, you can use that. If you use this, don't consider the magnitude. You have to take as it is on this part. It will be 1 over 3 minus the area that we got there, which is minus 1 over 3. Still going to have the same answer of 2 over 3. You use this formula. But this one, you have to consider that you are going to take the magnitude of what? Of the area that you are given. You are dealing with what? The magnitude of the area there. All right, so these are the typical questions that you might actually be given, and you'll be wondering, how am I supposed to answer or attempt such typical questions? You have to just play around with the information that you are given, sketch your graph, understand the information, the limits also that you are given. So now we want to check another part that at least maybe let us have an area that is bounded, then having the y-axis, because we're just having the x-axis. It's not like it's like that to say your area is just about the x-axis. No, it can be also be on the y-axis, as we saw that here, that our area can also be taken about the y-axis. All right, this is ax on the y. Am I writing ay? This is ax there, sorry. Then the area with respect to y here, whereby we've got our representative strip with respect to the y, and we talked about this. All right, so let us just have an example that we can just relate there. All right, let us say we're given in this case the graph of y is equal to the ln of x over 2. All right, this is a function of x. This is f of x. All right, taken in between y is equal to 0, x is equal to 0, and y is equal to 2, like this. This is where we are having this. All right, so this is a logarithmic function that we are having, a ln. So all you just need is to have the sketch. Remember, the graph of ln is given in this way. All right, we've got our x-axis here and our y-axis. Remember, the graph of ln is taken this way. This is the graph of a log function of a ln, all right, which is an exponential function of a positive is like this, or we can have an exponential function like this, but a log function is in this way. That's a log function, which is a ln in this case, okay? So meaning to say it will be tending as if it want to approach the y-axis, but as it goes, it will pass a point where here we have got a 1 in this case, I mean a 0 in terms of the value of y, but what will be the value of x? So what can we have? It's because our logarithm can be equal to 0 if this is a 1, if this whole part here is a 1. So in order for us to have a 1, it means our x has to be 2, so that we've got 2 over 2, which is 1. So at the point 2, our graph is going to be at 0 because we've got ln of what? Ln of 1, and ln of 1 is equal to 0. Remember, ln is a log, so there are no negative values, and also we do not have 0 there. Okay, let me just take you back to your calculator. Maybe you can understand what I'm saying. A ln is a log. This one is a log, so you can't have ln of a -2. This one does not even exist. So there are no negative values for this ln that we are seeing. They are only positive, and also there is no ln of 0, does not exist. The only part that we're gonna have to start functioning is at 1. So, and that 1 is when our x here is 2. So at the point 2, we are going to obtain a 0 in this case. Then it can start to increase as the values of x are increasing. Let us say we've got ln of 25. You can see that the values, they are just increasing a little bit from what we are having from the values. If you are given our value, maybe it's ln of 2, as you can see. So the values, they'll be just increasing as the x values are increasing, but not as much as we are having, right? So that is what we are having this, but this one is x over 2. So it will be a little bit higher on what we are expecting to have. So you can just have an increase of x as y is also increasing, just something of this nature. All right. So that's our log function. So it will be tending as it wants to approach. It won't approach the y-axis because we do not have a value in the y-axis. All right. So this is the graph of y is equal to the ln of x over 2. So you have to know your sketch. That was our part of N3, sketching of these typical graphs. So it's best for you to also relate from there. Then from this part that we are given, as we can see, it must be bounded between the line of y is equal to 0, which is the x-axis. So it's bounded by this line. It's bounded by the line x is equal to 0, this one. and the line of y is equal to 2. Y is equal to 2 can be somewhere here. So the region that is bounded, that is covered, is this one that is going to be left here, covered by the graph, covered by this line, covered by the y-axis, covered by the x-axis. This region here is not covered, so you can't be talking about this region. This one is not covered. Remember, it's open down here. We need the region that is bounded, covered by these axes. So we are going to have our region across. So you're just going to have the line of y is equal to 2, maybe somewhere here. That's the line of y is equal to 2. And the x-axis, which is y is equal to 0. So meaning say our representative strip is going to be in the y-axis. We cannot have this in the x-axis, but because we do not have like the value that is corresponding, if we can have like a region that we're going to be talking about to say, this one is bounded between, but there we are not given the limit. Where are we bounding our area to? So the area that is limited, that is covered, that is bounded is this one in between, like I indicated before, that is going to be within this region here. This is the area that is covered, bounded by the graph, the x-axis, the y-axis, and the line y is equal to 2. This is the region that is being covered, that is only remaining covered, bounded by all the lines that are indicated here, covered by all the information that we are given there. So you are ought to understand each and every part, or to understand each and every part that you are given. All right. So that's it. Let us find our integral. Remember, this time is the area that you're going to have with respect to y. So it means that we must have our function as x is equal to, because this is y is equal to ln x, but here the representative strip is with respect to y. So the area there with respect to y is supposed to be the integral of f of, it must be a function of y with respect to y, whereby this function of y is the one that we are saying x with respect to y with the limits c and d in this case. So we are going to need to write or to make x the subject of the formula to be x is equal to. So how are you going to make x the subject in this case? All right, this is what we have. Remember, the ln and log, the ln and exponential is just the inverse of each other. So if we are given y is equal to the ln of x over 2 like this, for us to have x, remember, you can just interchange this. All right, so that x is going to be, if we cross multiply, if we change, that will be x, y here, it will be x, then we interchange here, it will be ln of y over 2 in this case, then we make y to be the subject. So you have to interchange first, then we make y to be the subject. All right, so this will be y over 2. This is 2 affecting y, so not like out of this side, but under the y here. So it's one and the same thing. So meaning to say, we are taking this as a single term of y. So you're going to make y the subject there. All right. The first thing, you interchange these letters, then make y the subject again. So if we make y the subject, it's going to be, remember, a ln, there's a log there. It means x is equal to, take note, x is equal to the log of y over 2 like this in base of e. So whenever there is a ln, it means the log in base of e. So that's, if we are to make this the subject, if we are to write in back to the exponential form, this y here over 2 is going to be given as, so it is going to be y over 2 is equal to the base of e to the exponent of x. So it's going to be the base of e to the exponent of x. So that's e to the exponent of x. Remember the conversion that we have, the logarithm of a in base of b is equal to c. It means a is equal to b to the exponent of c. So it's a conversion that we are taking from our M3 there of writing or having in actually, and for the inverse of a certain function that you are given, especially this part of a log and exponential. So that's, we can make y the subject. If we cross multiply that side, you can just multiply by 2 both sides, by 2 both sides. So that means y is going to be e to the exponent of x times 2, which is 2e to the exponent of x. So we made y to be the subject, like we found the inverse. So this is the inverse that we want, but in this case, our inverse is not going to be written as y is equal to. This is a way of finding the inverse, but as we shall write as x is equal to, because we are supposed to have in terms of y. So this inverse that we simply means, it simply means that x is equal to 2e to the exponent of 2y in this case. All right, it was y is equal to, now it will be x is equal to. We just have to interchange there. All right, so that is the one that we are going to be working with in our integrals, of which if you are just given this by sight, you can just work it by sight. It's x over 2. I don't want to interchange anything. I can just introduce my logarithm direct here. I don't want to interchange anything. I just want to make x the subject, right? So I can just introduce the logarithm. Remember, the ln is the logarithm in base of e. So it means to remove this ln, it will be e to the exponent of y this side. So e to the exponent of y is equal to x over 2. I want to find x, simply multiply this by 2. This, if you know your laws, you're not gonna have to go back to your normal simplification. As you can see, that's what we gonna have. Why is this a 2y? There's supposed to be a y, not a 2 there. Just gonna want to check why. What happened? Is it on the final part of writing, or it was, okay, that's an x there. So it was just supposed to be 2y like that. All right, so that means that one is just a mistake that we had there. So it's just 2, not a y there. So it's not 2y there, it's just e to the exponent of y like that. All right, so if you are to check, this is how you can play around. You just have to make whatever that you're given the subject, and that's it. So now we can have this as the whole part here is going to be x is equal to 2e to the exponent of y, like that. So meaning to say, we are going to integrate this. So that's our x in this case, with respect to 2, with respect to y. So that's our area. With respect to y is going to be the integral of 2e to the exponent of y in this case, with our limits. So the limits now are the ones that are in the y-axis, because we are focusing here with a representative strip of the y. So in the y here, in the y-axis, that's where our limits are to be taken from 0 to 2. So that's why I'm using C and D, not A and B. A and B, we talked about them in the x-axis. Now we talk about the y-axis. You can use 0 and 2. That is C and D. So this will be your C, this will be your D. The lower limit at 0, the upper limit at what? Upper limit at 2, like this. All right. So that's it. Let us find our integral. Remember, e, like I said, e is going to be e to the exponent of over the function, the first derivative of that function. So if we've got e to the exponent of y over the first derivative of y there, that's a 1. So this one is just going to remain as it is. So that is 2e to the exponent of y with our limits 2 and 0 there. We're going to just substitute upper limit minus the lower limit in this case. So this time we do not have anything to be in radian or what. Just have to use your calculator in a normal way. There's nothing to be affected. So the upper value, that is 2, minus the lower value, which is at 0 there. Going to substitute the lower value. So that's it. We are going to obtain the area with respect to y in this case. That is the area affecting our graph, and let us just see, that will be something like 12,778 in this case to 3 decimal places. So you can just use your calculator direct to simplify this value here. So that's you can just have 2e. All right, that's e here to the exponent of 2. All right, minus 2e to the exponent of 0. E to the exponent of 0, it's a 1. So 1 times 2 is simply a 2 there. So we'll be having 12,778. So that is how you can calculate your area. You can just have your area direct like that. So like I said, we've got different scenarios that you're going to have in our calculation of area, and different values that you're going to have, or how we're going to calculate these areas. So not to miss any of these typical questions that we might have as a preparation for our exams. Make sure that you join the membership so that you'll be part of the revisions, unlimited revisions, as we are approaching our exams, or as we are revising towards our exams, be it from our past exam papers, be it the topics that have been covered and not yet polished up. So if you join up the membership, it helps us also to produce more content, so that it brings us more of our revisions towards these exams. So I just encourage you guys, if you are not yet part of the members, to join the membership family, so that we can reach others as much as we can. But for now, that's it. We shall see the next part, which is the area bounded by two curves or two graphs, and so on, and to the volume, up to we finish up this topic on the applications of our integration.